I know you really had a hard time in working your module for the second week, am I right? But despite of that, I am so glad that you really give your best in order to accomplish your task. So well done, everyone. Now let's come to the lesson that you must learn this week. So this time, I'm going to discuss about an arithmetic sequence. So what is an arithmetic sequence? When we say arithmetic sequence, it is a sequence that has a constant difference between the consecutive terms of the sequence. This constant difference is what we call common difference. And then the nth term or the general term of the sequence is given as a sub n equals to a sub 1 plus the quantity of n minus 1 times d, wherein the a sub 1 is the first term or the first data, and d is the common difference, and then the a sub 1 is the nth term. So again, this formula is the general formula of an arithmetic sequence. So that means you don't have to find any formula because this sequence has its own formula. We only just follow this one. So now, I'll give you an example of a sequence. Then let's find out if it is an arithmetic or not. Let's start with this given example. Let's say we have 2, 4, 6, 8, 10. So let's try to study this given example. We see to it that this is in arithmetic or not arithmetic. So again, in order to tell this sequence as an arithmetic, we have to find the common difference. That means if this sequence has a common difference, then we can say that this is an arithmetic. Otherwise, it is not an arithmetic. Alright, so in order to find a common difference of the given sequence, we just subtract the terms from the last to the first one. Alright, so let's subtract 10 minus 8 will give us 2. 8 minus 6 will give us also 2. 6 minus 4 will also give us 2. And 4 minus 2 is also 2. So this means that our common difference is 2. This is the D in the general term or the general formula of an arithmetic sequence. So how about this one? 3, 5, 7, 9, 12. So now let's check if this sequence has a common difference. So let's say 12 minus 9 will give us 3, and 9 minus 7 will give us 2, 7 minus 5 will also give us 2, and 5 minus 3 will also give us 2. Now observe, the difference are not common. It is because we have one difference that is not the same with the other. So therefore, this sequence is not an arithmetic. Again, the arithmetic sequence, the difference must be common. That is why what we call common difference. Okay? Now let's try to solve some examples of an arithmetic sequence by using the formula. The general formula of the arithmetic sequence. Let's say we have 5, 10, 15, 20, 25. Now, our task, we have to find the difference. When you see D, we are dealing with the common difference. And we have here A sub n. This referring to the general formula or the nth term of this given sequence. So now, in order to find the common difference, again, we simply subtract the terms from the last to the first one. So, 25 minus 20 will give us 5, 20 minus 15 will give us also 5, 15 minus 7 will also give us 5, and 10 minus 5 will also give us 5. So therefore, the common difference is 5. Simple as that. Now, how about the general formula? So if you remember a while ago, again, so the general formula is given as a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So we have to follow this rule because this is the general formula of an arithmetic sequence. All we have to do is to find the volume A sub 1 and the common difference. Then we simply substitute those values to this variable. Then we evaluate. And we have the formula. Alright, so we have here. The formula is this one. We have A sub 1 plus n minus 1 times d. So, we have here the common difference is 5. So, we simply substitute here the 5. So, we have here A sub 1 plus the quantity of n minus 1. Then, our d, we write as 5. Then, our first data is given. Remember, A sub 1 is the first data, and this is the first data or the first term. So, we simply substitute here as 5. So, we can rewrite here 5. Then, we evaluate. First, we have to distribute this 5 to the terms inside the parentheses. So, we copy first this one. Then, 5 times n will give us 5n. Then, 5 times negative 1 will give us negative 5. Then, we only have to combine these constants. So, we have here, copy 5n. Then, 5 or positive 5 minus 5, that is cancelled or that is 0. So therefore, the formula is simply 5n. This is the formula. A sub n is equal to 5n. Let's check. If our first term here, if n is 1, our first data is 5. Am I right? If n is 1, 5 times 1 will give us 5. Then if this is 2, 5 times 2 is 10. If this is 3, 15. Then, if this is 4, 5 times 4 will give us 20. And if this is 5, 5 times 5 will give us 25. So that means our formula is correct. So again, in order to find the n term or the general term or the general formula of an arithmetic sequence, you just follow this format. Only you have to do is to find first the value of the common difference and the first data. So I hope this is clear. So, can you now determine the value of the common difference and how to get the formula of an arithmetic sequence? Very well. Now let's try to find some of the indicated terms of an arithmetic sequence. Let's study this given example. Let's say we have 8, 12, 16, so on and so forth, and until to the 95th terms. So from this given example of an arithmetic sequence, we have to find the value of the terms in the 95th. Again, in order to find the value of the sequence, we have to follow the format of the general formula of an arithmetic sequence, which is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So, in order to find the formula, again, we have to find first the value of the d as well as the first term. But by using this given sequence, we have automatically the value of the first term, which is 8, because 8 is our first term. So we can substitute here 8 plus, we have to copy this one, n minus 1. Now, for the d or for the common difference, we have to subtract first the value from the last to the first one. So we simply subtract 16 minus 12 will give us 4. Am I right? Then 12 minus 8 will also give us 4. So this means the common difference of this given sequence is 4. So we have to substitute here 4 as our value for our common difference. So we have to evaluate now. So in order to evaluate, we have first to distribute this 4 to the terms in the parentheses. So, copy first 8 plus. Then 4 times n will give us 4n. And 4 times negative 1 will give us negative 4. Then we have to combine first the constant, this 8 and negative 4. So we have to copy first 4n. Then 8 minus 4 will give us positive 4. And this is the formula of this given sequence. So, we can automatically now find the value in the 95th terms by using this formula. We simply substitute the 95 for the variable n because we are referring to the 95th term. So therefore, n is the 95. So we have here a sub 95 because we are going to find the value of the 95th term. So our n simply is the 95. Then over 4, again our n is 95 plus 4. Then we simply evaluate this given expression. So 4 times 95 will give us 380 plus 4. Then we simply add. 380 plus 4 will give us 384. And this 384 is the value of our 95th terms. So this is our answer. Another example. Let's say we have 5, 12, 19, 26, so on and so forth. Then we have here 105th terms. So this time we're going to find the value of the terms in 105th. So again, we have to get first the formula of this given arithmetic sequence. So by following the format, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Then, automatic our first data is the first term because a sub 1 referring to the first term. So we have here 5 plus copy n minus 1. Then our d, we simply again subtract from the last data or the last term to the first data. So here 26 minus 19 will give us 7. Am I right? Then 19 minus 12 will give us also 7. And 12 minus 5 will also give us 7. So therefore, 7 is our value for the common difference. So we have here 7. Then we simply distribute again these 7 to the terms inside the parentheses. So we copy first 5 plus, then 7 times n will give us 7n, and 7 times negative 1 will give us negative 7. Then we have to combine first the constant. So copy 7n, then 5 minus 7 will give us negative 2. So this is the formula in this sequence. So we can use this formula again in order to find the value in the 105th term. So simply we substitute 105 to the variable n. So we are here a sub n. So instead of a sub n, we can substitute automatically the value of the terms, which is 105. Sorry for that. I have 105. Then 7. Then our n again is 105 minus 2. So 7 times 105 will give us 735. So we'll have 735, then minus 2. Then 735 minus 2 will give us 733. Therefore, this value is the terms in the 105th term. This is our answer. How about this one? Let's try this example. Let's say we have a sub 3 is equal to 9 and our a sub 8 is equal to 24, and our task is to find the value of the a sub 23 or the 23rd term of this sequence. So it looks like a pretty hard in dealing with these examples, am I right? But in this case, we have to find first the value of the common difference as well as the value of the first term. Because if we have the value of the common difference, it will lead us to the value of the first term, and also we can now find the value of this problem. So in dealing with this given sequence, we have to derive two equations, which means equation for this a sub 3 and equations for a sub 8. And in order to find the equations, we have to follow the format of the general formula of an arithmetic sequence. So we take first the a sub 3, then the general formula, we have a sub 1 plus the quantity of n minus 1 times d. Same with this a sub 8. So we have here a sub 8, the general formula, a sub 1 plus the quantity of n minus 1 times d. So this time we have to substitute first the value of these terms because these terms has given. So our a sub 3 is 9, so we substitute here 9. Then our a sub 8 is 24, am I right? So we have here, so we have to substitute 24 for the a sub 8. So that one. Then our problem is the n. Remember that the n is the number of terms. So our 9 referring to the third term, am I right? This example, the third term is 9. So therefore, we have here 9. It refers to the third term. So let's substitute here n as 3. Am I right? Then the 24 is referring to the 8th term. So therefore, our n here is 8. Then we have to subtract these two equations in order to find this common difference. So we subtract this one. Then 9 minus 24 will give us negative 15. Am I right? Then a sub 1 minus a sub 1 is 0, or that is cancelled. Because any number or variable that is subtracted by itself, the difference is always 0. That's why we cancel this one. Then this time, before we subtract, we have to distribute the d first to the terms inside the parentheses. That means we have to equate this one. I mean, we have to evaluate this one. 3 minus 1 will give us 2. Then 2 times d will give us 2d. Am I right? This 3 minus 1 is 2. Then we simply multiply to 2d. We have here 2d. Then 8 minus 1 will give us 7. Then 7 times d will give us 7d. And these terms is what we have to subtract. So we have here equals 2d minus 7d will give us negative 5d. Am I right? We simply copy the variable d. Then 2 minus 7 will give us negative 5. So from this given equation, we can find now the value of d simply by dividing all the terms by negative 5 because our d has the coefficient negative 5. So this is our target. This means that we have to cancel this negative 5. And to do that, we simply divide all the terms by this coefficient negative 5. So cancel this one and we have here simply d. Then negative 15 divided by negative 5 will give us positive 3. Am I right? So this means that our d is 3. So we have here, our d is simply 3. Now our problem is a sub 1. So in order to find the a sub 1, we can use either of these two equations. Then we simply substitute the value of d. Then now we have the first term. So I take this first equation. This is not this 9. So remember, this is our first equation, am I right? So we simply substitute here the value of our d, then we now evaluate. So we have first copy 9, then a sub 1 plus. Then 3 minus 1 will also give us 2. Then our d is 3, am I right? So we have here 3. Then we simply multiply this one. So 2 times 3 will give us positive 6 over positive 6. Copy this one and also this one. Then we simply transpose this positive 6 to the left of the equation such that only the a sub 1 is on the right side of the equation. So we have here 9. Then we transpose this one. once we transpose, we always change the sign. So the positive 6 will become negative 6. Then the remaining is only the a sub 1. Then we simply subtract 9 minus 6 will give us positive 3, and that is the value of our a sub 1. So we have here our a sub 1 is simply 3. So our common difference is 3, and also our a sub 1 is 3. So now we have the value of our d and a sub 1. So we can substitute this to the general formula of an arithmetic sequence in order for us to solve this given problem. So we have here a sub n is equal to a sub 1 plus the quantity n minus 1 times d. So our problem is the 23rd term. So automatic our n is the 23. So we substitute here 23, and the n here is also 23. Then substitute the value of a sub 1, which is 3. We have here 3. So we have here 3. And for our d, we have here also 3. So we substitute here 3. Then we simply evaluate in order to find now the value of the 23rd term. So we simply copy first this 3 plus, then 23 minus 1 will give us 22. Then we have to multiply this 22 by 3. So 22 by 3 will give us 66. Am I right? So we have here 66. We simply copy the remaining terms. Here a sub 23. Then we simply add 66 plus 3 will give us 69. So here a sub 23. So the value of our a sub 23 or the 23rd term is 69. So I hope this is clear. Now, can you determine some indicated terms of an arithmetic sequence using the given sequence? Very good. Now let's proceed to the arithmetic series. When we say arithmetic series, we simply get the sum of an arithmetic sequence. It is very easy for us to find the sum if only the given are the first 5 terms or the first 10 terms. But how about if you're going to find the sum of the first 100 terms, or the first 200 terms, or worse, the first 1000 terms? So it is really time consuming for us to solve those terms manually. To further explain, let's watch and study this given example. So before I present to you the example of an arithmetic series, I will give you first the formula. The formula in getting the sum of an arithmetic sequence. So first we have S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. So the n is referring to the number of terms, then a sub 1 is the first term, a sub n is the last term. Another, we have S sub n is equal to n over 2 times 2a sub 1 plus the quantity of n minus 1 times d, where the a sub 1 is also the first term, n is the number of terms, and d is the common difference. Now I will give you the difference of these two equations. The first formula can be used if you know what is the first term and the last term, while the second formula can be used if you know the first term and the common difference. This formula is the most used in getting the sum of the arithmetic sequence. But again, you can use either of these two formula. Their answer is the same. So now I will show you the example of an arithmetic series. Let's say we have 4, 9, 14, 19, so on and so forth. And we have to find the value of the sum of the first 20 terms. So now we have the first term. We have the a sub 1 because our first term is the first data. So we have a 4. And only the problem is the common difference. But we can determine the value of the common difference simply by subtracting all these terms from last to first. So 19 minus 14 will give us 5, am I right? 14 minus 9 will give us 5, and 9 minus 4 will give us 5. So therefore, the common difference is 5. We have here 5. So now I have the first term and the common difference. So I use the second formula, which is S sub n is equal to n over 2 times 2a sub 1 plus the quantity of n minus 1 times d. I use this because I have the first term and the common difference. So we simply, I have here, our target is the sum of the first 20 terms. So our n is 20. This is our n. So over here, s over 20. And our n here is simply 20 over 2. Then 2 times our a sub 1 is, we have here 4. So we substitute here 4. Then plus our n again is 20 because we're dealing with the first 20 terms. So we're 20 minus 1 and our d is 5. So we simply evaluate now. 20 divided by 2 will give us 10. Then 2 times 4 will give us 8. Then 20 minus 1 will give us 19. Then we have to multiply this by 5. Then we have to multiply this one first. 19 times 5 will give us 95. So here 95 plus, we copy 8 and also 10. Then 95 plus 8 will give us 103. So we have here 103. Then we have here 10. So we multiply this 103 by 10. And to finalize, we have to multiply these two numbers. 10 times 103 will give us 1030. So this means that the sum of the first 20 terms of this given sequence is 1030. So I hope this is clear. Another example for an arithmetic series. Let's say we have our a sub 1 is 5 and our a sub 6 is, let's say, 30. And our task is to find the sum of the first 6 terms of this given sequence. So I have already the value of the first data because the first term or the a sub 1 is given. But I don't have the value for the common difference. And it's really time consuming if I get the value of the common difference. If we observe the given problem, our task is to find the first 6 terms, and our given is the a sub 1 or the first term and also the 6 terms. So therefore, we have the value of the last term because we have the value of the 6th term and our target is the first 6. So therefore, we have the last term. So I can use the first formula, which is in the form of S sub n is equal to n over 2 times a sub 1 plus a sub n. The a sub 1 is given as also the last term because our n is 6 and I have the value for a sub 6. So therefore, this formula is applicable. So let's substitute. The n is 6 because we are referring to the sum of the first 6. So we have here s sub 6 and our n is 6 over 2. Then our first data is 5 plus our last data is 30 because a sub n referring to the last term and our last term is 30. So here 30. Then we simply add the terms or the numbers inside the parentheses. So 6 divided by 2 will give us 3 and 5 plus 30 will give us 35. Right? Then, we simply multiply. 3 times 35 will give us 105. And this is the sum of the first 6 terms of this given sequence. I hope this is clear. Now, I hope you already know how to find the sum of an arithmetic sequence. Now let's come to the arithmetic mean. When we say arithmetic mean, we simply inserting a certain terms between the given two terms. Without further ado, let's study this given example. So here are the examples of an arithmetic mean. Let's say we have insert 5 arithmetic means between 6 and 42. So we have to analyze first this problem. It says we have to insert 5 arithmetic means between 6 and 42. So we have the first one, 6. We have to insert 5 terms of 1, 2, 3, 4, 5, and that is the 42. So we have here the 5 arithmetic means, and the first data is 6 and the 7 data is 42, or the 7th term is 42. I'm right, so we have 1, 2, 3, 4, 5, 6, 7. So in order to find the mean of the arithmetic, we have to find the common difference. So to do that, we simply have an equation of these given terms. So this 42 is the 7th term, so therefore we have a sub 7. We simply use the general formula, which is a sub 1 plus the quantity of n minus 1 times d. And this time, we have the first data, which is 6, because the 6 is the first term. So we substitute here 6 plus, then our a sub n is also given. Am I right? The a sub n, this one, the 7th data or the 7th term is 42. So we substitute also here for the a sub 7, we have here also 42. Then our n is referring to the 42. That means 42 is the 7th terms of this given sequence. So therefore our n is 7 minus 1 times d, because 7 is referring to the 42. Okay, then we simply evaluate the numbers inside the parentheses. We copy this one. 7 minus 1 will give us 6. Then we multiply that one. 6 times 2 will give us 6d. So this, I guess this one will be erased. Okay, sorry for that. Then we have here 42. Then in order to find the common difference, we have to transpose these terms to the left side of the equation. So we have here 42 minus 6. It is now negative because here it is positive. Once we transpose that, it becomes now negative. So the right side, only the remaining terms is only the 6d. Then, so I will move it right here. So here 42 minus 6 equals to 6d. And then we have to combine this one. 42 minus 6 will give us 36. That is equal to 6d. We simply copy this one. Then our target is to find the d, so we have to cancel the coefficient of d. So to do that, we have to divide all the terms by 6. Am I right? So our d, 36 divided by 6 will give us 6. So therefore, the common difference of this given sequence is 6. We use this common difference such that we can insert the 5 arithmetic means. So we simply add this common difference to the first term. Again, we simply add the common difference to the first term. So we have 6 plus 6, because 6 is our difference, common difference I mean. So 6 plus 6 is 12.
Then 12 plus 6 is 18. 18 plus 6 is 24. 24 plus 6 is 30. And 30 plus 6 is 36. Then 36 plus 6 is 42. So therefore, the 5 arithmetic means between 6 and 42 are 12, 18, 24, 30, and 36. So that is the only way in getting the arithmetic mean of the given arithmetic sequence. So I hope you really now understand all the ideas that I had been discussed to you. If you have some clarifications, please don't hesitate to chat. And before I end this video, I want you to solve the exercises given on your Moodle. But last, and not the least, don't forget to answer your weekly test. So use your prior knowledge and the knowledge that you had been learned from this video. So I guess this is now the end of this topic for this week. Goodbye, class. Keep safe and God bless.